So this is Chapter 9, Section 1, Polar Coordinates. We are going to be rocking and rolling our way through and getting to vectors, which is really exciting. So when we are talking about polar coordinates, we call the line from 0 to the right the polar axis. We call the origin the pole. So everything starts from this line right here, leading off to the right. So we're going to plot some points using polar coordinates. When we're talking polar coordinates, we're talking a radius and an angle. So your angle tells you how far from the polar axis you've rotated, and the radius tells you how far out at that angle you're going. So for example, if you have a polar coordinate of 2 comma pi over 4, 2 is your radius, that's how far out you go, that's your distance, and pi over 4 is your angle. So you go pi over 4, or 45 degrees, and then out 2 units from there. So the point you end up at is right here at 2 comma pi over 4. All right, so the radius, if you have a negative radius, he takes you in the opposite direction. Normally we would go an angle theta and then out along that angle. What a negative radius does is it reverses your direction by 180 and takes you in the opposite direction. So if we're going to plot the point negative 3 comma 2 pi over 3, we go ahead and go around with 2 pi over 3, and then we go out 3 units 180 degrees, or pi radians from our original angle. For some reason. All right, so we're going to plot some points and just for some practice. So my suggestion is to have some polar coordinate graphing paper on your graph paper. Okay, so when we have 3 and 5 pi over 3, I always do a little mental conversion to degrees because my brain is trained to work in degrees, and radians are still kind of all right. So 5 pi over 3 is all the way around. And then we're going to go out 3 units, so 3 circles out if you're on polar graphing paper. So it's like at 300 degrees. This next one, we're going to go negative pi over 4. So we're going to start at our polar axis, go back pi over 4 degrees, and then we're going to be 2 units out along that angle. If I am here, we have C, we're a radius of 3 and an angle of 0. Angle of 0 is on the polar axis, and we just go out 3 units. And last but not least, we're going to go -2 for a radius and pi over 4. So we go up to pi over 4, and then we're going to go 2 units in the reverse direction. Okay, so we're going to plot point P with polar coordinates 3 comma pi over 6 and find other polar coordinates r theta that have the same point. So here is our pi over 6 with a radius of 3. So the first one we're going to look at is when we have a positive radius, but our angle is between 2 pi and 4 pi. So we've already gone around the circle once, that's 2 pi. And we're going to add another pi over 6 to it. So 2 pi plus pi over 6 is 13 pi over 6, and we still have a radius of 3. That would be another polar coordinate that has the same point as 3 comma pi over 6. The next one that we're looking at is when r is less than 0. So I'm going to keep my angle between 0 and 2 pi. And what we're going to have to do is find the angle that is 180 degrees or pi radians away from pi over 6. So we add pi to pi over 6 and get 7 pi over 6. Our radius has to, so if we're at 7 pi over 6, we need to get back to pi over 6. We use a negative radius to push us back in that direction. Last but not least, instead of going pi over 6, we're going to go the opposite direction. So we go 2 pi minus pi over 6. And we want to put it in the negative direction, so it's 11 pi over 6, and with a radius of 3. So those are 3 different polar coordinates with the same ending point as 3 comma pi over 6. Hold on. All right, so here's a point with polar coordinates r theta, where theta is in radians, because we can be represented by any of the following. So the same radius, but theta is added by 2 pi k, or negate the radius and add pi plus 2 pi k, where k is any integer. So this is like a little formula for finding a coordinate that ends in the same place. The polar coordinates of the pole are 0 comma theta, where theta can be any angle. All right, our next learning objective is to convert from polar coordinates to rectangular coordinates. So the formulas we use to convert from polar to rectangular is x equals r cosine theta and y equals r sine theta. These ones come from sine theta equals y over r and cosine theta equals x over r. We used those in the previous chapter. So we're just taking the same formula we've been using and solving them for x and y. And remember, theta is this angle between the pole and the radius. We know what the radius is. It's the distance from the origin to the point. X is the distance horizontally. Y is the distance vertically to that point. So if we're going to find the rectangular coordinates given these polar coordinates, we're just going to plug in these values for r and theta. So for A, x is equal to r cosine theta. R is 6. Cosine of pi over 6 is root 3 over 2. Oh man, remember that unit circle that we made like 2 chapters ago? We're still using that thing. Okay, so it's 6 times root 3 over 2, and that simplifies to 3 root 3. So that's the x coordinate for this. To find, we still have to find the y coordinate. So y is equal to r sine theta. So that's 6 times the sine of pi over 6, or 6 times 1/2, which is 3. So the rectangular coordinate that corresponds to 6 comma pi over 6 is 3 root 3 comma 3. All right, let's do the same thing with b. R is -4, and theta is -pi over 4. So if we look at that picture, we see that here we are, -pi over 4. Normally 4 would be out in this direction, but we have a -4, so it pushes us out over here. So we're going to go x equals r cosine theta, which is -4 cosine of -pi over 4. Cosine of -pi over 4. So if -pi over 4 puts us in quadrant 4, the x value or the cosine values are positive in quadrant 4. So the cosine of -pi over 4 is root 2 over 2 positive because we're in quadrant 4. We multiply that by -4 and we get -2 root 2. Do the same thing for our y coordinate. R sine theta, we get -4 sine of -pi over 4. So here we are again, fourth quadrant, y values and sine values are negative. So we have -pi over 4, we're out 4 units, but in this case we're taking the sine. So sine in quadrant 4 is negative, so we get -root 2 over 2. And we multiply that by a -4 and we get 2 root 2. So our coordinate, our rectangular coordinate that matches up with -4 comma -pi over 4 is -2 root 2 comma 2 root 2. All right, so now let's go the opposite direction. Let's convert from rectangular to polar. So if we have a coordinate 0, 3, we're going to go ahead and plot the point and make a note of which quadrant we're in. So 0, 3 is over 0 up 3. Now we have to figure out our r value. And if you remember, r is x squared plus y squared equals r squared. We can use the distance formula. In this case, because we're on an axis, the distance is easy to determine. It is 3. So the last step is to figure out our theta. Well, looking at this, I know that's 90 degrees or pi over 2. So our coordinate is going to, in polar form, is 3 comma pi over 2. Other possibilities are -3, -pi over 2, and 3 and 5 pi over 2. All right, so the relationship is as follows. If x comma y is equal to a comma 0, then r theta is equal to a 0. If r theta is equal to a comma pi over 2, then xy is equal to 0 comma a. It's just putting into mathematical symbols what we just saw in the previous problem. if x comma y is negative a comma 0, so it's out at 180 degrees, then r theta is a comma pi. And lastly, if we're at 270 or 3 pi over 2, x comma y is 0 comma negative a, and r theta would be a comma 3 pi over 2. These are, you don't have to write these down because you can use your logic to come up with these every time. Okay, so let's find out what the polar coordinates are when we have 2 comma negative 2. So we're going to plot the points so we can figure out which coordinate, which quadrant we're in. So over 2 down 2 gives us quadrant 4. We're going to use the distance formula, r equals x squared plus y squared square root, to find our r value. So when we do that, we get 2 squared plus negative 2 squared, which is 4 plus 4, which is 8. So the square root of 8 is 2 root 2. So our r is 2 root 2. Now we have to find theta. When we're finding theta, we always want to use tangent. So we're going to go tangent of theta equals y over x. So theta is inverse tangent of y over x. We are, where theta is between negative pi over 2 and pi over 2, because that's the only place where tangent is valid, where we can find the inverse. So we get inverse tangent of negative 2 over 2, or inverse tangent of negative 1, and we get negative pi over 4. Now we're going to take a moment and go ahead and do this in your calculator. To make sure you have your settings correct. So when we're looking at theta ends up being negative pi over 4. So a set of polar coordinates that correspond to the rectangular coordinates 2 comma negative 2 is 2 root 2 comma negative pi over 4. Some other possibilities are 2 root 2, 7 pi over 4, or negative 2 root 2, 3 pi over 4. Okay, let's do that for coordinates that are in the third quadrant. So negative 1, negative root 3 is in the third quadrant. We use the r equals square root of x squared plus y squared to find our r value. We get negative 1 squared plus negative root 3 squared. That's 1 plus 3, which is 4. Square root of 4 is 2. So we find theta. We say that we're not going to find theta directly, because when we inverse tan, we get the angles between negative pi over 2 and pi over 2. That's from here to here. We are in quadrant 3, so we have an issue. So we're going to find alpha using this inverse tan of negative root 3 over negative 1. Since we're in quadrant 3, an inverse tangent function gives an angle in quadrant 1, we are going to add pi to the result to get an angle in quadrant 3. So our theta is going to be pi plus what we get when we do an inverse tangent. So we're going to inverse tangent root 3, and we get pi over 3. We're going to add pi to it, because pi over 3 is here. We want to be in quadrant 3. So we're going to add pi to pi over 3 and get 4 pi over 3. All right, so if you're in quadrant 1, your R value is the square root of x squared plus y squared, and theta is inverse tan of y over x. If you're in quadrant 2, your radius is the same, x squared plus y squared square root, but your theta is pi plus whatever you get out of your tan. Same with quadrant 3. Radius is the same. Theta is pi plus whatever you get out of your inverse tan. And then quadrant 4, radius is the same. Theta is just what you get out when you do inverse tan of x over, or y over x. So to summarize, when we're converting from rectangular to polar, plot the points. If we're x equals 0, y equals 0, we can quickly find r theta. If we're not, then r is equal to the square root of x squared plus y squared. And then to find theta, quadrant 1 or quadrant 4, we just inverse tan of y over x. Quadrant 2 or quadrant 3, we go inverse tan of y over x plus pi. All right. Transform equations between polar and rectangular form. So we were doing coordinates, now we're going to do equations. So we're going to use these properties. R squared equals x squared plus y squared, and y equals r sine theta. And we reserve the right at any moment to use x equals r cosine theta. So we're going to transform this equation, r equals 4 sine theta, from polar coordinates to rectangular coordinates, and identify the graph. So we're going to multiply both sides by r. Because how are r, x, and y related? They're related by an r squared. So multiply both sides by r. We know r squared is equal to x squared plus y squared. We know that r sine theta is equal to y. So we substitute in r squared for x squared plus y squared, and we substitute in r sine theta for y. This is the circle. So now we have rectangular coordinates. 3x squared plus 3y squared equals 2x. So we're going to transform it from rectangular to polar coordinates. We're going to go ahead and substitute. Well, let's go ahead and factor out the 3, and then substitute in r squared for x squared plus y squared, and substitute in r cosine theta for x. I divide both sides by r, and I get 3r equals 2 cosine theta. And that's it. Polar coordinates.